So for the last example, I want to use one of the pieces of data that we used before. Let's compare on those exam scores that we had, exams 1, 2, 3, and 4. We already found significant differences between, like, there was 2 hard exams and 2 easy exams. So like, I think 2 and 4 had low scores and 1 and 3 had high scores, something like that. And 1 and 3 were very similar and 2 and 4 were very similar, but like the hard ones were definitely harder than the easy ones. And we had found that in straight up comparisons. I'd like to see what that looks like in ANOVA, because we could actually compare all 4 exams at the same time. Now ANOVA is only going to detect just sort of some kind of difference. It's like, so it could be that all like 3 exams are the same and 1 is different, like, or it could be like we expect, like this sort of like 2 and 2, or it could be that all 4 are different from each other. ANOVA can't tell. It can only tell if they're all the same or if they're not all the same. But I want to see how ANOVA runs on a bigger set of data and 4 groups. So I'm going to open that file that has our ANOVA sample, our exam data sample. So this was from 417. I have a folder for the 417 stuff, and I called that file exam data. We'll open that up, and data has column names, yes. And it looks like it's separated into columns like it should, so we'll hit OK. And yeah, the column names are up separate, and row 1 has the first set of data. And I never did go back and sort of fix these in the file that I keep uploading, so I have to fix all these zeros again. This is like the 4th time I've done this. Luckily, there isn't 20,000 rows like there is with the project data, so this doesn't take very long. I think I got all the zeros. Okay, so let's see what ANOVA looks like comparing all 4 exams, and we'll also get to see the graphs that go with them then. So ANOVA, one way, get rid of these. We're comparing exam 1, exam 2, exam 3, and exam 4. I don't think you have to do these one at a time. I think you can highlight them all. Here, let me try that. So can I highlight them all and then hit select? Yeah, can move them all over at once. Okay, so I'm expecting there to be a significant difference because we found a significant difference when we were just comparing them one-on-one between the hard and easy exams. But so I'm expecting a low p-value here, but I think it'll still be interesting to see the graphs, to see like visually how much harder exams 2 and 4 were than exams 1 and 3. Okay, so our p-value extremely small as expected. It's 0 until 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's the 10th decimal place. 4, 5, 6, 7, 8, 9, 10. Yeah, I think that's the 10th decimal place. We finally get something that's not 0. So extremely small p-value. So we have very strong evidence that these exams are not equally difficult. And you can see in the graph, here's exam 1 and 3. They sort of had means in sort of like the low to mid 40s. And then there's a gap, and exams 2 and 4 were down in sort of like the high 30s. And like the highest that we would expect that the mean could be, not just for these, 40 students or whatever we have, what is it, 60 students? If I gave this to thousands of students, like we're sort of expecting that the mean on exams 2 and 4 would not really go above like 38 or 39, and the means on exam 1 and 3 wouldn't really go below like 41. And so there's like a solid gap between the 2 hard exams and the 2 easy exams. There's definitely no sort of line that you could draw that goes through all of the bars. So comparing sort of the up-down variation between going from one group to the next, the up-down movement going from one group to the next is big compared to the width of the bars. So that comparison of the variance between groups to the variance of each group is showing that there's definitely a difference somewhere between these exams. Small bars compared to how much they move up and down means there's a difference. Big bars compared to how much they move up and down means that they overlap a lot and there isn't a significant difference. Okay, so our last one had a very, very small p-value. We know that these exams were not equally difficult. And if we want any more information than that, well, that's why we're generating the graph. So we can see that the reason that we got a small p-value is because there's sort of two high ones and two low ones, and they were clearly separated. The high ones are clearly separated from the low ones by a good sort of like 2% gap of possible means in each of those groups. All right, so that's ANOVA. It's not really any more complicated than that. I'm not planning to spend more than one day on ANOVA. It's just if you need to check more than two groups of quantitative data, you can just fire it through ANOVA. It's not going to give you a lot of information other than whether or not the groups are all equal, but it's a really easy test to run. Okay, so that's it for today.